Hello and welcome to Ms. Ma's Advanced Functions class. This is 8.2, Transformations of Logarithmic Functions. So we're going to be transforming f of x equals log base m of x. M is the base, so it's basically going to tell us what the parent function is. It's not a new transformation, it's just telling us the parent function. In this case here, my graph is y equals log base 10 of x. So we know that log is the inverse of the exponential, so the inverse of that would be y equals 10 to the x. We know it has points like 0, 1, 110, and 2, 100. And we also know that it has a horizontal asymptote at y equals 0. So that tells us that for the log, which is the inverse, we're going to flip the points. So whatever the x was is going to be a y, and whatever the y was is going to be an x. And you'll notice I wrote log x because if you don't have a base written in, it's assumed that it is base 10. So we'll just reverse the numbers here. So instead of 0, 1, we get 1, 0, 10, 1, and 102, and then we get a vertical asymptote because the y's turn into x's, so the vertical asymptote becomes x equals 0, and that's what log base 10 of x looks like. And you can see I've got my 2 points here, and of course I don't have any more points because they're really far away, but I do have my asymptote at x equals 0. And so we could transform this function, or you might be given a different base. For example, we could have log base 2 of x, which is the blue one. So y equals log base 2 of x. And you can see it still has the same x-intercept and the same vertical asymptote, but its shape is slightly different. It's just a little bit more round here because we go through 2, 1, 4, 2, and 8, 3. So you're reversing the 2 to the x. And so depending on the base, you could get a slightly different shape, but what we want to talk about is the transformations. So if we're transforming y equals a f of k x minus d plus c, and f of x equals log base m of x, then we're looking at y equals a log base m of k x minus d plus c, and all of these letters still stand for the same thing. So a is the vertical stretch and flip, k is the horizontal stretch and flip, D is the horizontal translation, left and right, and C is the vertical translation. That's going to be up and down. Ooh, excuse my writing. So this question asks us why the range never changes. And to answer that question, we're going to look at the graphs. So log base m of x, it could be different based on the m, the base. So if m is greater than 1, then it's going to look something like this, where I've got the vertical asymptote and it approaches infinity off in quadrant 1. It has an x-intercept of 1, 0, and if it is between 0 and 1, then it's actually going to open the other way. So it's going to approach infinity in the infinity, and then approach negative infinity really slowly in quadrant 4. And it has the same x-intercept at 1, 0. And that's just if you have a fraction for your m. So you'll notice also that your m cannot be negative. It must always be positive. So it's just different based on whether it's less than 1 or greater than 1. But either way, you'll notice that for the range, which is what the question asks us, there is no limitation on the y values, right? I can go up and down no matter how far down I want to go. I'm still approaching the asymptote, and no matter how far up I want to go, there's still always log for the positive version. So the range is y in R. And because it's infinite, we know that transformations cannot affect infinity. They're not going to limit infinity. So that is why the range will never change. The transformations affecting the asymptote, in fact there's only one. You know that the asymptote is actually a vertical asymptote. And so it's one that goes up and down, and if we wanted to change it, we'd have to move it left and right. So moving it left and right is a horizontal shift, horizontal translation. So it is the d value that changes the vertical asymptote. So for example, if we had something like y equals log base 3 of x minus 1, we know that changes it, and the vertical asymptote would be x equals 1. And also, this is going to affect our domain. Our domain would be x in R. such that x is greater than 1. And it's usually greater than 1 because we can only do the logs of positive numbers. However, this doesn't affect the asymptote, but it does affect the domain. If I have a horizontal flip, as in I'm flipping over the y-axis, then I know that I do change my domain. So if I had y equals log base 3 of negative x minus 1, my vertical asymptote is still x equals 1, but my domain now becomes x in R, such that x is less than 1. And we should know what the range and the domain are by just looking at the equation. Okay, so we're going to do one example. Write the equation of the logarithmic function of base 10 that has a vertical asymptote at x equals 3, a vertical stretch by 3, and a vertical shift 4 up. So we're going to assume that those are the only things that we have. So vertical stretch by 3 means that a is equal to 3, and a vertical shift upwards means c equals 4. We still have to write those in even though they don't affect the range. It does make the graph look a little bit different, of course. And we have a vertical asymptote at x equals 3. We know that this is only the d that is affected, so d is equal to 3. So if we use our original y equals a log base 10, I don't have to write the 10 because it's assumed, kx minus d plus c, and because k has not been mentioned at all, we're going to assume that it is 1. We get y equals 3 log base 10 of x minus 3 plus 4. And there you go. That's the answer. Okay, I hope you enjoyed it. Ask me any questions you have in class. And if you find any problems, just report them in the comments below with a timestamp, please. I hope you enjoyed it, and I will see you in class. Bye.